Okay, this is a tutorial that will help you to pass the CCNA. If you plan on passing the CCNA, you need to completely understand this chart to answer the types of questions that are going to be thrown at you on the test. This is networking fundamentals, and when we're communicating computer to computer or host to host or end device to end device across the internet or across a network, the data that goes across the network is broken down into pieces, which we use the colloquialism packets to describe how the data is broken apart into packets and sent across the internet. And this communication follows a set of rules, and those rules are broken down into a model which follows the rule of these layers that happen. And right here I've got a couple of models on the left hand side of this chart, and these models are models that govern network communication across networks. And the two models, you've got the OSI model, which is a reference model that a lot of vendors and engineers base their developments, their protocols, and their services and their devices on. They base it on the OSI model. And then the TCP/IP model, which is the model of the internet. This is the model that is in use today on the internet. And the two models correlate to one another. So for instance, in the OSI model, we refer to it as layer 5, 6, and 7 here. They correlate to the application layer on the TCP/IP model. And layer 4 of the OSI model, the transport layer, in the TCP/IP model, it's also called the transport layer. And then layer 3, the network layer on the OSI model, is the internet layer on the TCP/IP model. And then the bottom two layers of the OSI model, the physical layer and the data link layer, correlate to the network access layer in the TCP/IP model. All right, and as data is broken apart and sent over the internet, it happens in a layered, linear layered way. So you have some data and you want to send it. You're using a web browser, and you want to send a request for a web page. You want to get a web page. Well, that message, that request is data. Okay, and the format here is data. And you'll see in this column I've got, this is called PDU, or Protocol Data Unit. And as that data is broken apart and sent across the internet, it's the packet that's formed goes through certain stages in which information is added to that data and broken apart and then sent. So we're going to talk about that right now. So at that top layer, when you're formatting that request to the web browser, you're dealing with data. At layer 4, the data is broken apart into pieces called segments. At layer 3, those segments are added, packets are added on, packet headers are added on to the package at layer 3. At layer 2, frame headers are added to the package. And then at layer 1, the package is encoded into bits and then sent across the internet. And when it reaches its destination, the data is built back together in the same order. The bits are received, the frame is stripped off, the packet's stripped off, segment header is stripped off, and then the data is rebuilt from all of the packets that are received. So, and these are the protocol data units. And you have to understand and you have to memorize which PDU, which protocol data unit, operates at what layer. So it's imperative that you know that when I'm talking about packets in the test or in the Cisco CCNA, if they're talking about packets, they're talking about layer 3, the network layer. And if they're talking about a frame, they're talking about the data link layer, and so on and so forth. So it's very important to understand that for the test. We start communication from the user, and that started at the application layer, at the topmost layer when you're working with data. And you can see here under protocols on the application layer, I've got HTTP, SMTP, FTP. Well, HTTP, that's the protocol for a web browser. SMTP, that's the protocol for email. FTP, file transfer protocol, and you'll see these other protocols here. So all of these protocols relate to a service or a process or program or an application, i.e. the application layer, a network application that you can use to communicate across a network or across the internet. Okay, and then we have some other protocols here. We've got at the presentation layer, the data is formatted and then presented to the user. And so we've got different formats. We've got JPEG, which is compression, zip compression, MP3 file. We've got ASCII text. You have different types of formats and compression schemes and security that can also be put on at this layer. Then I'm going to we'll skip the session layer for right now, and we'll talk about the transport layer. The protocols that operate at the transport layer are TCP and UDP, and it's very important. As you can see, the model is called TCP/IP. TCP is a very important protocol on the internet. And at this point, at layer 4, where a segment, where the data is broken into segments, the headers, the segment headers are added to the data, to each piece, and they'll have what's on them called port numbers. And the port numbers will be in those headers, and there'll be source and destination port numbers. And those port numbers will refer to which application is making the request. So if you've got a port number of 80, then you know the request is from is towards an HTTP web browser. So you want a web page, in the segment it'll have a port 80 number in the segment, and then when the data arrives at its destination, the computer is able to figure out, port 80, you want a web browser, you want a web service, you want a web page. At layer 3, packets. Packets have IP addressing information inside of the packet headers. They've got source and destination IP addresses, and IP addressing is the routed protocol. IP is the routed protocol of the internet, and every computer on the internet has to have an IP address. So this is oftentimes called a logical address because you configure it through software. You configure it through your operating system. The IP address is configurable. At layer 2, the frame is technology dependent. So in this case, we're usually talking about, at this layer, an Ethernet frame. Let's say on our local network, usually Ethernet is the protocol du jour at layer 2 on local area networks. And at this point, we're talking about MAC addresses. So MAC addressing, every computer that has a Ethernet NIC or network interface card has a burned-in physical MAC address, burned right into the card, a unique address that identifies each computer individually on the internet or anywhere. If you have a NIC, you have a MAC address, and that's a unique address. At layer 1, this is the bottom layer of the OSI model, right? It refers to the TCP/IP model as the network access layer, which groups the data link and physical together. At the physical layer, we're dealing with the media, or the medium, meaning usually wires, the Ethernet cables, or radio waves, or fiber optic cables if we have fiber optics. So at the physical layer, we're talking about media, and the PDU, the form that it takes at this layer, is bits. So the data is broken apart. Each segment, each package is broken apart, encoded into a bit scheme, and then sent over the wire as a bit scheme, pulses of voltage signaling ones and zeros sent across the wire. And so this is an introduction to this layered architecture. And you can see that certain devices operate on certain layers. So I've got that listed here too, which devices operate on which layers.